Say one at 1. Half-life, comparing linear and exponential functions. Warm up, define each term and provide an example. 1. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is a constant called the common difference. 2. A geometric sequence is a sequence in which the ratio of any two consecutive terms is a constant ratio. All right, go ahead and complete that. Let's take a look at the next page. Getting started. Asymptotic, don't you think? When you work with sequences, you often use something called repeated reasoning. This means that you notice when a pattern repeats and think about how a pattern will extend when repeated. 1. A square is shown. Use a rule to draw a line segment that divides the square in half. Then draw a second line segment in just 2 halves you create to divide that segment in half. Continue like this until the division becomes too small to make. All right, go ahead and complete that. All right, go ahead and mark out 2. 3. Write the explicit formula you could use to determine the area of the small section. Explain your reasoning. A sub n equals a sub square times parentheses 1/2 n to the minus 1, where n is a halving of the square starting with n equals 1. 4. What would happen to the area of the smallest section if you could keep dividing the square forever? The section area would approach 0, but there would always be some tiny amount of area remaining. Let's take a look at the next page. Activity 1.1. Arithmetic and geometric sequences. Allison and Beth each receive $10 per week for doing chores for the neighbor. One day, Allison decides to increase her income using her knowledge of exponential growth. She proposes that her payment change to a penny for the first week and then double each week thereafter. All right, let's go and complete 1. Complete the table to represent the amount that Allison and Beth will earn each week. All right, so Allison will be 0.01 cents, then 0.02, 0.04, 0.08, 0.16, 0.32, 0.64, 1.28. All right, and Beth will be $10, then $20, then $30, then $40, then $50, then $60, then $70, then $80. All right, go ahead and finish completing the table. Two. How does Allison's income change as the number of weeks increase? As the number of weeks increases by 1, the amount that Allison earns multiplied by 2. 3. Does Allison's income represent an arithmetic or geometric sequence? Explain your reasoning and state the general formula. Allison's income represents a geometric sequence because the dollar amount is increasing by a constant ratio. 4. Write an equation to represent Allison's income, A sub n, after n weeks. A sub n equals 0.01 times 2 to the n minus 1. Let's take a look at the next page. 5. What is the value of A sub n for n equals 0? Does this value make sense in this problem situation? A sub n equals 0.01 times 2 to the 0 minus 1. Let's go ahead and use our calculator to do that. Which is 0.005. Okay, no, the value does not make sense because there is no currency with half a penny. Let's take a look at number 6. If the pattern were to continue, how many weeks would it take for Allison's income to be the same as Beth's income? Let's let n equal the number of weeks. So that Allison's income equal to Beth's income. And we need to graph and find the point of intersection. So let's go ahead and do that now. Okay, so we're going to graph 0.01 times 2, and we have to use x So then x minus 1 and 10x. All right, and let's go ahead and zoom out until we find the point of intersection, which is right there. So let's round that to a whole number, which will be 15. So it will take 15 weeks for their income to be the same. All right. Go ahead and look over the worked example. All right, let's take a look at the next page. All right. Calculate the income that Allison would earn per week in each week given. All right, so let's go ahead and use Desmos. And we want the scientific calculator. So that's 0.01 times 2 to the All right, go ahead and finish up 7A, B, and C. All right, number 8. Predict the shape and characteristics of the graph that models Allison's income as a function of the number of weeks. The graph will be a discrete set of points which increase sharply from left to right. All right, let's take a look at the next page. Activity 1.2, linear and exponential models. Beth is amazed at how quickly Allison was able to make a lot of money and decides that she wants in on the action. She asks her two friends, Quentin and Alicia, to help come up with the plan. 1. Consider Quentin and Alicia's plan. Whose plan should Beth choose? Complete the table and graph to justify your reasoning. Round to the nearest hundred. Quentin, you could start with $1 and ask for 50% more each week. Alicia, you could start with $1 and add another $1 each week. Let's go ahead and do 2 first, and we'll go back to number 1, the table and graph. Write a function derivative in Quentin's plan, q of x, and Alicia's plan, a of x. Q of x would equal 1 times 1.5 to the x minus 1. A of x would equal 1 plus parentheses x minus 1. All right. Using Quentin's equation, let's go ahead and fill in the data for the table. So what we're going to do is 1.00 parentheses 1.5 to the, now it says error, who cares? Now all I have to do is plug in the x value for each time. All right, now let's do an x is 2. Now let's do x is 3. there is your all right, let's go and graph Quentin's points in yellow. So 1, 1, 2, 1.5 is about right there. 3 is 2.25, about right there. 4 is 3.38, which is about right there. 5 is 5.06. You're going to have to approximate. 6 is 7.59. And 7 is 11.39. Alright, now let's go ahead and fill in Elisa's plan using her equation. So 1.00 plus parentheses x minus 1 gives us an error. Who cares? X equals 1. Alright, let's go ahead and graph that in pink. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Alright, go ahead and finish up the table and graph. Alright, let's take a look at the next page. Three, use your choice from question 1 to determine how much Beth will earn in week 10. All right, so let's go ahead and use our calculator. So that's 1.00 parentheses 1.5 All right, using Quentin's plan, she would make $38.44. Now let's take a look at Lisa's plan. All right, using Alicia's plan, she would make $10. Using Quentin's plan, Beth will earn $38.44. And using Alicia's plan, Beth will earn $10. All right, go and finish up number 3. Let's take a look at number 4. Beth and Allison both start using their exponential models to earn income at the same time. Who will earn a higher income in week 12? All right, so let's take a look at that. So that's 1.00 parentheses All right. And let's take a look at the other equation. Okay. Beth will earn a higher income of $86.50 in week 12 compared to Allison's income of $20.48 in week 12. Let's take a look at number 5. Use technology to determine when Allison and Beth's incomes will be equal. Does this make sense in a problem situation? All right, let's go ahead and go to Desmos graphing. All right, and let's go ahead and zoom out and find out when they're equal. Now you're going to have to zoom out quite a bit, and there's your point of intersection, which let's round to a whole number of 17. So the incomes will be equal in 17 weeks. Number 6. Compare Allison's and Beth's function models. A. As the number of weeks continues to increase, whose model will generate more per week? Allison's model is better over time. Beth's model earns her more money per week in the beginning, but after 17 weeks, Allison's income is more. B. Consider the A and B values of the exponential functions. How do they further support your claim? Allison's B value, or her income rate of growth of 2, is larger than Beth's B value, or her income rate of growth of 1.5. So Allison's income will surpass Beth's income after 17 weeks. All right, go and finish up your notes and have a wonderful Wildcat day.